Hello, welcome to my Pre-Algebra review series. This video covers Chapter 9, Section 3, titled Classifying Polygons. By the end of this video, you will have reviewed your knowledge of classifying triangles and classifying quadrilaterals. This will be followed by a real-world problem to solve. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's get going. Okay, to start, we have a couple definitions. One, a polygon. A polygon is a closed plane figure with at least three sides. The sides must meet at their endpoints. A regular polygon has all sides congruent and all angles congruent. We'll look further into that as we get into this section. Objective 1, classifying triangles. A polygon is a closed plane figure with at least three sides. The sides must meet at the endpoints. A triangle is a polygon with three sides. You can classify triangles by angle measures. You can also classify triangles by side lengths. Tick marks are used to indicate congruent sides of a figure. So let's start. There's 6 of them here in this little picture. Acute triangle. An acute triangle has 3 acute angles. And acute means less than 90 degrees. And as you look at this one here, you can see that like this one here, the right triangle has one, right here, I'll draw right there, 90-degree angle. And they usually depict it with a little angle like that to show it's a right angle. Anyways, acute angles, these angles, all 3 of these angles, as you can see, are less than 90 degrees. This is an acute triangle, 3 acute angles. A right triangle has one right angle. I already drew it in. One right angle, and the other 2 are less than, or the sum of them is 90 degrees, but each of them have to be less than 90 degrees. Okay? An obtuse triangle has one obtuse angle. An obtuse angle is this angle right here. It's an angle that is greater than 90 degrees. So any angle greater than 90 degrees out to a straight angle, which is 180 degrees, is obtuse. An equilateral triangle. An equilateral triangle has 3 sides, and with these tick marks, you see they're congruent. They're equal to each other. Congruent, the same exact length. An isosceles triangle has 2 congruent sides. Okay, so you see by the tick marks, this side down here on the bottom has 1 tick mark, but the 2 on the side have 2 tick marks. They're saying that this is an isosceles triangle and it has 2 congruent sides. A scalene triangle has no congruent sides. And by tick marks, you see it here. This side is not similar to this side nor this side. 1 tick, 2 ticks, 3 ticks. All side lengths are different. Okay, so that's that. Example 1, classifying a triangle. Classify a triangle by its sides and angles. This triangle has 2 congruent sides and 1 right angle. So what type of triangle is this? So here are the congruent sides. So we're showing we have an 8-inch side here and an 8-inch side here. So if I'm going to tick mark it, it would be like a single tick on each of those. So these are congruent, and it has 1, I'm going to draw this in red, and 1 right angle. So this is an isosceles, since it has 2, it's not equilateral because it's not 3 equal sides, it's 2 congruent sides, 8 inches, and a right triangle. So it is called an isosceles right triangle. Example 1, check your understanding. It's your turn. Judging by appearance. Classify each triangle by its sides and angles. So I'll wait. When you get back, we'll go over them. Okay, now that you're back, let's look at A. What is triangle A? Well, based on the previous slide that told us the different types of slides, one thing for sure, this triangle A, by appearance, it doesn't say by fact, but by appearance, it appears to be a right triangle. This appears to be a 90-degree angle. So I'm thinking that it's certainly a right triangle. But there's one other thing. What else could we classify it as? Not an isosceles right triangle, or all three sides are different. Okay, they're different. So that would be a scalene. So I think we'd say scalene, S-C-A-L-L-E-N-E, right, R-I-G-H-T, triangle. A scalene right triangle. No sides, 1, 2, 3. No sides equal. Now here we have two sides congruent with the one single tick mark. So it's two congruent, so it's two sides congruent, not three. So that makes it isosceles, and I-S-O-S-C-E-L-E, isosceles. And the noticeable thing about this angle right here is this particular angle right there is greater than 90 degrees. So we're going to call that obtuse. O-B-T-U-S, obtuse triangle. Okay? And finally, C. This is obviously it's obtuse. We talked about this angle larger than 90 degrees. So this is obtuse. And the other interesting thing is this is no sides congruent. So this would be a scalene, obtuse, triangle. Okay? Do we get it? Scalene's easy because there's no tick marks to indicate. We don't have to prove anything on congruent sides. And two of these happen to be scalene. And you'll find it's mostly scalenes all the time in your work in the future. Okay? Objective 2, classifying quadrilaterals. So these are four-sided figures from the word quad. Right here, quad means four sides. So here's what we're going to look at. And what are they? So a quadrilateral has four sides. So they're showing you it can be any figure. It doesn't really matter as long as it has four sides. It's a quadrilateral. And then from there we can get a couple different types right off the bat. We can get this trapezoid, which shows it has two sides. A trapezoid has two sides that are parallel. Right here. And it doesn't have to be the bottom and top. It could be the sides. But two of the sides are parallel. And they say exactly one pair, as we see here. And the other sides, they're not parallel. They're just sides of any angle that they want. Okay, a parallelogram, by the other way, though, other than a trapezoid, if these sides were parallel here on this side and this one here on the trapezoid were parallel, it would be a parallelogram. Both pairs of opposite sides are parallel. So this is parallel to this side, and this side here is parallel to that side. A parallelogram. And from a parallelogram, we have two other figures. One is a rectangle. It has two sets of two sides parallel to each other, and four 90-degree angles. Okay? Four 90-degree angles. That makes it a rectangle. A rhombus has four congruent sides. It just has four sides of the same length, but they're not talking about parallelism of the... So this would be like a single tick. All have the same length, but we don't know about what the angles are. Okay? And then finally, both of these will reduce into squares, and a square has four equal sides, four congruent sides. Congruent, 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 and four 90-degree angles. Okay, that's what's special about a square. Four 90-degree angles and four congruent sides. Example 2, classifying quadrilaterals. Name the types of quadrilaterals that have both pairs of opposite sides parallel. Well, to name some, a rectangle, a square, a rhombus, okay, here's some of them. Name the types. There are more. As we go down here and look, all parallelograms, all is the key here. All parallelograms have opposite sides parallel. Parallelograms include the rectangles, rhombuses, and squares. Okay, so that's that for that one. Okay, example 2, check your understanding. It's your turn. Name the types of quadrilaterals that have 4 right angles. So go ahead and give it a shot. When you come on back, we'll do them together. Okay, I'm sure you're back and you've had your time to think about it. So here's the answer. We want 2 of them. It says name the types of quadrilaterals that have all 4 right angles. There's only 2 available. So one of them is a rectangle. A rectangle has 4. If we look at it, you can draw it, right? 4 90 degrees, right? And what's the other type of rectangle? Well, a square. It's a special kind of rectangle, but it has 4 sides equal to each other, but it also has 4 90-degree angles. So it's a square. Oops, there we go, square. Okay. Okay, example 3, a real-world problem to solve here. So a contractor is framing a regular octagonal gazebo. Write a formula for the perimeter of the gazebo in terms of the length of the sides. Evaluate the formula for the side length of 7 feet. Okay? So to write a formula, let's let x be the length of each side. So we're going to let x, we're going to go right over here. And so the length from here to here, for example, is 7 feet. Okay? 7 feet. That's what we have here. It says the perimeter of a regular octagon is x plus 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 x, however many, 8 times 8 x's. Okay, as you see here, starting with this one we just drew, 1, 2, 3, 4, 5, 6, 7, and 8. That's what a hexagon, where does it say hexagon? Oh, an octa here. Octo is 8. So it's an octagon. Okay, so therefore the formula is P, as it's written here. P is equal to 8 times x. And given that 7 is the length of x, we now know that the perimeter of this thing is going to be P is equal to 8 times 7. And that's going to be equal to 56. Okay? Okay, example 3, check your understanding. We're going to, it says solve. So what they want us to do is write a formula. It says write a formula to find the perimeter of a regular hexagon. And I'll tell you that hex means 6. Use a formula to find the perimeter if one of the sides is 16 centimeters. So go ahead and give it a shot. Come on back when you're done, and we'll get started. We'll finish this section with this slide. Okay, now that you're back, write a formula to find the perimeter of a regular hexagon. Hexagon. So what is a hexagon? A hexagon is, so we're going to 1, 2, here's this one, and we got a side over here, and a side here, and a side here, and a side here. 1, 2, 3, 4, 5, 6. Hexagon. Okay, just like before, what is the, so it's 6 times whatever the length of the side is, right? So, and we'll say that x is equal to the length of the side. So P, the perimeter, is equal to 6 times x. And if we substitute here, down in this one, we're going to know what the perimeter is, right? So that's the formula. So now using the formula, P is equal to 6x. We're now going to substitute 16 centimeters for the x. So P is equal to 6 times 16 cm. And then we carry that math out. We're going to find out that it's 96 cm, centimeters. 96 centimeters around that hexagon, the perimeter of it.